Hi everyone. So today we're going to carry on with more u-substitution. Okay, so these examples are going to be a bit more difficult than what we did last time, but I'm sure we can all manage with that. Also, you should notice on your Learn 2022, all of your summative tutorial test 1 mark should be up. Okay, so I've marked everything now, all the marks should be up. If you have any issues with the marking, please let me know as soon as possible, and then I can take a look at that. Okay, but let's carry on with the examples. So we're going to start off with an easy one just to get into it, and then we'll move on to the more difficult ones. Okay, so number 1, we have the integral of cos 2x dx. Okay, so like I mentioned before, if this was just cos of x, then that would be easy to integrate. We know how to do that. But here we've got a problem because it's cos of 2x. Okay, we don't know how to integrate cos of 2x. That's something too difficult. So what we do is we say u is equal to 2x. So now it's going to become cos of u, which is easier to do. But we can't have cos of u dx, that doesn't make sense. Instead of dx, we need to find du. So how do we do that? Well, we're given u is equal to 2x. So from this, we can write du is equal to du by dx, dx. It's the conversion between x and u in terms of the differentials. So now du is going to be du by dx is going to be 2. So it's going to be 2 dx. Okay, but that's a problem here because if we look back at our original integral, we see we just have dx here. We don't have 2 dx, we just have dx. So we need to take this 2 and take it over to the other side. So now it's going to become 1/2 du is equal to dx, which is what we have. So that's fine now. Okay, so 2x is going to become u, and dx is going to become 1/2 du. So let's just write that on the side. So 2x, we're going to replace with u. That's from here. And dx, we are going to replace with 1/2 du. That's from here. So those are the two things we're going to replace. So let's do that. So this now becomes the integral of cos of u and dx. Remember, we said we're going to replace that with 1/2 du. So this is going to be 1/2 du. Okay, so we can write this as 1/2 the integral cos of u du. Now this is very simple to do. We know how to do this. The integral of cos, that's going to be sine. So this is going to be 1/2 sine of u, and don't forget your plus c. Okay, so we're still working with indefinite integrals, so you have to remember your plus c. Okay, but this is in terms of u. The original question here was in terms of x. So we need to go back to x. So remember, u was equal to 2x. So this is going to become 1/2 sine of 2x plus c. Okay. Are there any questions about this one? Okay, so remember this u substitution is all about this replacement over here. So we need to do these replacements. Okay, so after doing the replacements, we see that the integral becomes much easier to do. Okay, but remember, once you've solved it in terms of u, we always need to go back to x, because that's what we started with. You can't leave your answer in terms of u. Okay, any questions before we carry on? Okay, let's look at the next one. Okay, number 2, we have the integral of x squared, just x, and then 2x squared plus 3 to the power 4 dx. Okay, so this looks similar to what we handled before, but remember, if the exponent is 2, then, it's easy to expand out. We can write it as a polynomial. But here the exponent is 4, so it's a bit more difficult than that. But we see that this inside part is what's making our lives difficult, because it's 2x squared plus 3 to the power 4. So if we can get rid of this inside part, then it's just going to be something to the power 4. And that's a lot easier to do. So this gives us the hint that u should be 2x squared plus 3. Now remember, there's no set rule to tell you what u should be. But again, like I said before, if you do lots and lots of examples, you will see, what should I let be u, and then what will become du. Okay, so that just comes with practice and experience. But here we can see we've got this inside function to the power 4. So that's a very good hint that this inside function should be u. Okay, so we've got u now, but remember, we also need to find du. So du is going to be du by dx dx. So du is going to be, if we differentiate u, we're going to get 4x dx. Okay, so let's see with our original expression, we've got x dx. That's the leftover part. So I highlighted the part in yellow, the leftover is in red. We have x dx. Here we've got x dx, but we've also got this extra 4. Now there's no 4 in the original expression, so we need to take it over to the other side. So now we get 1/4 du is x dx. Okay, and then that shows up in the original expression, so we're good with that. So what replacements are we going to do? 2x squared plus 3, we are going to replace that with u. That's what we said at the beginning here. And x dx, we are going to replace with 1/4 du. That's the second bit that we've got here. Okay, so let's do the replacement and see what we get. So this is equal to the integral 2x squared plus 3. That's going to be replaced with u. So we have u to the 4. X dx, that's going to be replaced with 1/4 du. Okay, so these two over here, we replaced in our original integral. Okay, so this now becomes 1/4 the integral u to the 4 du. And this over here, after doing the replacement, is much easier than what we started with. We see the integral in terms of x, that was very complicated. We did the change of variables, we made the replacement, and now it's much easier to do. Okay, so let's do this much easier integral. So we're going to have 1/4 times, we add 1 to the exponent to make it 5, and then divide by 5. So that's 1/5 u to the 5, and don't forget your plus c. Okay, so 1/4 times 1/5, that's going to be 1/20 u to the 5 plus c. But remember, we don't want to stay with u variables. We want our original x variables. So remember, u is equal to, what did we put? 2x squared plus 3. So 2x squared plus 3. Okay, so let's put that back. So this is now going to be 1/20 2x squared plus 3 to the power 5 plus c. Yeah, and that's done. So you see, it's much, much easier after we do the substitution. Okay, any questions about this one? Okay, so I hope you're all getting the idea of what you should let be u in this case. So here we see that this inside part, 2x squared plus 3, is being raised to the power 4. So that gives us the hint that this part here should be u. Yeah, but again, there's no set rules for this. It just comes with experience. So you have to do lots of problems, and then you'll pick up on what should be u for each of the cases. Okay, any questions before we move on? Okay, let's take a look at another example. It's number 3. So here we have the integral sine squared, let's write that a bit better. Sine squared theta cos theta d theta. Okay, so this looks pretty complicated. We've got this trig integral to try and solve. Let me rewrite it a bit, and then maybe it will be more clear what we should let be u. So this is equal to the integral sine squared as it's written there. We can also write that as sine theta squared cos theta d theta. Okay, so maybe if we write it like that, it will be a bit easier to spot. So if you just look at this now, what should we let u be? Any ideas? So u equals, what should we have?
I think sine theta.
Yeah, that's right. Sine theta, because we see that it's inside here. Okay, so it's inside the brackets with the squared. So we should let that be u because it's some inside function. So again, there's no fixed rules, but typically if it's an inside function like we have here, then that should be u. Okay, so yeah, you're right. So u equals sine theta. So what about du? So du is going to be du by dx dx. Sorry, not x, we're working with theta. Du by d theta d theta. So du equals, what are we going to get?
I think cos theta.
Yeah, so du by d theta is cos theta. And then remember the d theta being multiplied. Okay, good. So let's take a look at what we've got so far. Sine theta squared is going to now be u squared. Cos theta d theta, that's this part over here. That's going to become du. So sine theta is going to become u. And cos theta d theta is going to become du. Okay, just from our calculations that we've got here. Okay, is there anyone that doesn't see that? Okay, cool. So let's do the substitution. So sine theta squared, remember sine theta becomes u, so this is going to be u squared. Cos theta d theta, remember our calculation here, cos theta d theta, that's going to become du. And you see, again, this is much easier to solve. So the integral of sine squared theta cos theta d theta, that's very complicated. We don't know how to do that. We do this change of variables we write it in terms of u, and now this becomes much easier. So we're just using the power rule now. It's a lot easier than before. So let's do the power rule. We add 1 to the exponent to make it 3, divide by 3. So we get 1/3 u cubed plus c. Okay, but we're not done yet. We don't want to write it in terms of u. We want to write it in terms of theta. We want the theta variable. So this is going to equal, what are we going to get for our final answer? Any ideas?
I think it's going to be 1/3 theta cubed plus c.
1/3? Not theta cubed, because remember u is sine theta. So it's going to be sine theta cubed. So sine theta cubed and then plus c. Okay, so remember here, u is equal to sine theta. Okay, and then we get our answer. Okay, are there any questions about this one?
Yes, I've got a question.
Yes.
So are we going to leave out the du is equal to cos theta and d theta?
Yeah, so the cos theta d theta, this part here, that part just becomes du from this bit over here. So it's just a replacement. So we're not leaving it out, we're just replacing it with du.
Oh, okay, I understand.
Okay, awesome. Yeah, so we don't leave anything out with this. Over here, these are the replacements. So the replacements or the substitutions, however you want to say it.
Okay, so like the final answer, why don't we substitute for the value of du for recording our final answer?
Because after the integration here, so here after we do that, the integral goes away. So we're just left with an answer in terms of u. Like if you have the integral of x dx, then your answer is 1/2 x squared plus c. So there's no more dx or anything. It's just a function of x now.
Okay, it makes sense.
Yeah. So it's just like the integral in terms of x, but now we've got the integral in terms of u. So that's our new variable, u. But it's exactly the same as an x integral. It just looks different. Okay, any other questions from someone else? Okay, cool. Let's take a look at another one. This is number 4. Okay, so now we have the integral of x cubed over x to the 4 minus 5 squared dx. Okay, a bit more complicated now. So it's not super obvious what should be u, but would anyone like to give it a go? So u equals, what should we try?
X cubed.
No, not x cubed. So I'll give you a hint. If you've got...
It'll be x to the power 4 minus 5 because it's enclosed in parentheses raised to the second power.
Yes, that's right. Yeah. So here at the top, we've got x cubed. So the power is 3, right? But in the bottom, we've got x to the 4 minus 5. So you should pick the one with a higher exponent. Because remember, I'll just show you now. So we've got u. If we try to find du, that's going to be du by dx dx. Okay, so remember we're using the higher exponent. So du is going to become 4x cubed dx. You see how we get the lower exponent back. So you pick u to be the expression with the higher exponent, because when you differentiate, you get the lower exponent for free. So that's this part over here. That will be your du bit. Okay, so that's just a little, something to help you remember what should be u and what isn't u. Okay, but we've seen now when I circled this, we've got x cubed dx. But in our du expression, we've got 4x cubed dx. Okay, we don't want this 4 over here. So let's take that over. So we're going to have 1/4 du is equal to x cubed dx. Okay, which is what we've got. I circled that in red. Okay, so which replacements are we going to make? So x to the 4 minus 5, I'm going to replace that with u. That's our first replacement. And x cubed dx, I'm going to replace that with 1/4 du. That's my second replacement. Or second substitution, whatever you want to call it. Okay, so let's do that. So we have 1 over x to the 4 minus 5, all of that squared. But x to the 4 minus 5, that's going to be u. So it's just 1 over u squared. X cubed dx, I'm going to replace that with 1/4 du. Okay, so I've just done those two replacements. Is anyone confused with those replacements?
So can I ask why 1 over 4 is transposed to the opposite side of the equation in part 2?
Oh, okay, sure. So if we look back at our original integral, this bit here, so if I just highlight this in red here, we've got x cubed dx. But over here, there's a 4. Okay, we don't want the 4 there. So we take the 4 across. So we're just left with x cubed dx, which is what we've got over here. So we just manipulate it until we get what we want, which is the x cubed dx. And then all the other stuff we take over to the other side.
Okay.
Okay. Any other questions? Okay, cool. Let's have a look here. So now we can take this quarter out. So it's 1/4, the integral. Since the u squared is at the bottom, let's take it to the top. But then remember, we need the minus exponent. So we can write it like that. So this makes it a bit easier to do the power rule. Okay, so we add 1 to the exponent to make it -1, and then divide by -1. So it will be -1/4 u to the -1 plus c. Okay, but remember, we don't want it in terms of u, we want it in terms of x. So recall that u is equal to x to the 4 minus 5. So wherever we see a u, we're going to put back the original x to the 4 minus 5. So this is going to be equal to -1/4, and then we're going to have 1 over x to the 4 minus 5, and then plus c. Okay, and then that's our final answer there. Are there any questions so far? Okay, so it's not too bad. So the only difficult part is like the very beginning where you're trying to figure out what should u be. That's pretty much the only difficult part. Once you've done that, you just need to find du. And then if you need to manipulate it a bit like we did here, you do that. you make the two replacements or the two substitutions, you solve the easier integral, and then you need to remember you have to go back to x. So you can't just leave it in terms of u. Okay, so not much to do. Yes, you got a question?
Are we always supposed to leave u in a positive exponent?
Oh, no, you can leave it with negative exponents. That's fine. So over here, if you wrote -1/4 x to the 4 minus 5 to the -1 plus c, that's perfectly fine. You'll get all the marks for that.
Oh, all right, all right.
Yeah. But if you want to write it like the fraction, that's fine as well. They're both the same. Okay, let's take a look at the next one. What are we on now? Number 5. Okay, example 5. Okay, so here we have the integral of the square root of 1 plus cos x times sine x dx. Okay, so you're going to help me again with this one. So u equals something. What should u be equal to?
Sine x.
Sine x. So remember what I said before? The hint as to what u needs to be should be an inside function. So remember you have f of g of x. This inside part, that should be u. Okay, it should be an inside function. So let's take a look at this again.
1 plus cos x.
Yeah, the function inside the root. Yeah, that's right. Okay, so it's always this inside part here. Because we've got the square root, that's the outside function. And then we've got something inside the square root. So that's what we should let be u. So in this case, u should be 1 plus cos x. Okay, everything inside the square root, we let that be u. So du is going to be du by dx dx. So du is equal to, what are we going to get if we take the derivative?
Minus sine x.
Yeah, perfect. Minus sine x dx. Okay, but let's look back at our original thing. We've got here sine x dx. So what do we need to do so that we get sine x dx? Okay, so this is what we want. Okay, so what do we need to do for the next step?
Divide by -1.
Yeah, exactly. So we're going to have minus du is equal to sine x dx. So we've got the sine x dx in the red box there. So we've got it in the red box here. Okay, so that's what we've got here. Okay, so we've got our two replacements that we need to make. So the first one is 1 plus cos x. We are going to replace that with u. The second thing is sine x dx. We're going to replace that with minus du. Okay, those are the two replacements. So let's do that. So the integral, the square root of 1 plus cos x. Remember, 1 plus cos x, we are going to replace with u. So this becomes square root of u. sine x dx, that gets replaced with minus du. Okay, so those are the two replacements. We replaced 1 plus cos x with u. We replaced sine x dx with minus du. Okay, are there any questions about the replacements we made? Okay, so it's not too bad. Let's make this look a bit nicer. So we can take the minus out, and then the square root of u, we can write as u to the 1/2. Okay, because remember, it's always easier working with powers than it is working with roots. So same thing as always. We add 1 to the exponent, so then it becomes 3/2. But then we need to divide by 3/2, which is the same thing as multiplying by 2/3. Then we have u to the 3/2, and don't forget your plus c. Okay, so remember our first replacement here. If we go back to x, what is our final answer going to be? Okay, so we've got the replacement here in the box. So I don't want to write it in u, I want to write it in terms of x. What do I get for my final answer? Okay, I'll give you a hint. It starts with minus 2/3.
So it's going to be minus 2/3 multiplied by 1 plus cos x to the exponent 3/2 plus c.
Perfect. Nice. Cool. So we got it. So then this is our final answer. Okay, so here's everything we did. Are there any questions on this one? Okay, so it's really not much. So you just do a bunch of practice, and then that will help you figure out what u should be. And then you got u, you find du, you do your replacements, solve the easier integral, but then remember you need to go back to your old variable. So you have to do, you have to write it back in terms of the old integral, the old variable. So instead of u, we write it back in terms of x. Okay, we got through quite a bit today. That was good. So I'm going to just leave you with some homework. And then if you have any questions on this homework, you can just email me or let me know on the WhatsApp group. Okay, and then this evening, I'll post all the solutions so then you can have a look. Yeah, so a little bit of homework. Just 3 questions. So we have the integral sine of root x divided by root x dx. Number 2, we have the integral 3t minus 1 to the 50 dt. And number 3, we have the integral of the cube root of 1 plus 7x dx. Okay, so just 3 things for homework. Okay, so I will post the answers on the WhatsApp group this evening. Okay, but give it a go for now, and then you can look at the answers later on. Okay, so tomorrow we will carry on with this u-substitution, but with a bit of a change. We're going to do u-substitution with definite integrals. So for the past 2 days now, we've been doing u-substitution with indefinite integrals, remember no bounds, tomorrow we're going to have a look at u substitution with definite integrals. There's just one more step that gets added. Okay, so it's not too much more work, just one more step that you need to keep in mind. Okay, and remember, next week, Wednesday, is test 1. Okay, so 9th of March, test 1. The Monday and the Tuesday, we will be using for test revision. Okay, so I'm going to write up a practice test. I will upload it on Friday, so you have the weekend to look over that. And then we will cover that test on Monday and Tuesday. So it's going to be exactly the same format as the real test, but the questions are just going to be different. Okay. Okay, so we'll cover that on Monday and Tuesday. Okay, any questions about that? Okay, so I will see you tomorrow for the u substitution with definite integrals. And then Monday, Tuesday, we do the revision, and then Wednesday, you write the test. Okay. If you do have any questions later on, please just email me or post it on the WhatsApp group. Okay, then I can have a look. Okay, I'll see all of you tomorrow. Bye, everyone.